Hello everyone and welcome back to our channel Quaint Cosmos. You know the name of Maxwell. You know Maxwell's four equations are there. So Maxwell means I am right now talking about James Clerk Maxwell, 19th century physicist. So you know there are so many scientists like Gauss, then Faraday, then Ampere. Okay. So many scientists are there, and again Coulomb is there. Okay, so many scientists are there, but up to that time, means during that time, during the period of Maxwell, actually electricity and magnetism both were separate subjects. Electricity and magnetism both were separate subjects. Anyway. So what did Maxwell actually do? He collected all the four equations, that is first two equations, you can see all the equations on the screen in integral form. The equations are available both in integral form and differential form. So here on the screen you can see all the equations in integral form. So you know first equation is known as Gauss's law, okay. But the Gauss's law, that means that is Gauss's law for electric field. Okay, second law, Gauss's law for magnetism. Third law, that is known as Faraday's law of electromagnetic induction, or only Faraday's law of induction. Sometimes we say only induction and sometimes we say electromagnetic induction, but both are same thing. Okay, and the fourth one is known as Ampere-Maxwell law. Originally the law was not Ampere-Maxwell law. Originally the law was only Ampere's law. Okay, but later, and that was the starting point. Maxwell found that there is a problem with Ampere's law. A correction was required and he made the necessary correction, and that correction is known as the introduction of displacement current. You can see the expression for displacement current on the screen. Anyway, so he corrected the equation because Ampere's law was valid only for steady flow of electricity. But for changing electricity when, say, for example, alternating current is present. So you know that alternating current, that means that current is constantly changing. So in that case, there was a need for correction, and that correction is known as displacement current. Anyway, so Maxwell corrected Ampere's law, and you can see the corrected form here on the screen, and the new name is given Ampere-Maxwell law. So you can see four equations, and these four equations are known as Maxwell four equations, though actually Maxwell developed 20 equations with 20 variables. But later two physicists, Heaviside and one more physicist is there, they actually reformulated and made only four equations. And all those four equations are known as Maxwell's four equations. But just keep in your mind that originally number of equations were 20 with 20 variables. Okay. Anyway, so after discovering these four equations, Maxwell solved all those four equations. And he found an expression for wave speed in terms of permittivity and permeability of free space. He gave us the idea that changing electric field creates a magnetic field, and changing magnetic field creates electric field. Maxwell gave us this idea. That means together they can sustain a wave which can propagate through free space. Together, okay? Combined effect of those things. Those two statements, changing electric fields create magnetic field. This is the first statement. Second one is changing magnetic field creates electric field. So jointly means combined effect of these two statements is what? Means they can sustain, okay, they can sustain a wave which can propagate, which can travel or propagate in free space. And when he calculated the wave speed by using the numerical value of permeability and permittivity in free space, he got the result to be 3 into 10 to the power 8 meter per second, that is 3 lakh kilometer per second or 300,000 meter per second. Approximately this was he obtained by just using the universal constants, permeability of free space and permittivity of free space. And before that, speed of light was measured, and that was also 3 into 10 to the power 8 meter per second. So Maxwell found that the speed calculated using this, you can see the mathematical expression for C on the screen, okay. C is equal to 1 by root over of mu 0 into epsilon 0, where mu 0 is permeability and epsilon 0 is permittivity. So astonishingly, he found that this calculated value and the speed of light are matching. They are same. Then he told us that, means actually he explained to us that light itself is an electromagnetic wave. Before that, that was not known to anybody. Speed of light was known, but light itself is an electromagnetic wave. That was not known to anybody. For the first time, Maxwell gave us this idea. Light itself is an electromagnetic wave, and that's why they are matching. Because the expression used for C is equal to 1 by root over of mu 0 epsilon 0, that is for electromagnetic wave. Anyway, so we came to know that light itself is an electromagnetic wave, and you know that after this discovery of electromagnetic waves, we came to know many things like X-rays, gamma rays, then infrared rays, microwave, so many types of electromagnetic waves are there. Okay, visible light is also, whenever we say light, that means that is visible light. Anyway, so all these electromagnetic waves could be explained by his theory, means by Maxwell's theory. And you know that after this discovery, we can see today's world, internet, Wi-Fi, okay, so many things are there, satellites are there, mobile phones are there, means our smartphones, and everywhere we can see the use of electromagnetic waves, and all these things have become possible only due to the discovery of Maxwell. So we cannot ignore the contribution of Maxwell. No doubt Maxwell was a genius in mathematics as well as imagination, and for that thing, the combined effect of mathematics and imagination gave us today's world. Okay, that is the combined effect, imagination as well as mathematics. Anyway, so this was all about today's topic, Maxwell's legacy. So we are living in a world where we cannot neglect or ignore the contribution of Maxwell, because I have mentioned only few names such as internet, Wi-Fi, smartphones, etc. But so many things are there without which today's world cannot be imagined. Anyway, so this was all about today's topic, and this is the end of this video. If you found this video to be fascinating, so please in that case like, share and subscribe to our channel. Okay, see you in the next video. Thank you for watching this.